Okay, now let's say you have a problem like this and you look at this thing, it's not a fraction like the previous problems, like you can't divide by the highest power of something because it's not a fraction anyway. Even if you try to make this a fraction, the cost will go up there. It will still give you some drastic problems, you know. But anyway, this is where you need to apply. As soon as you see the cos or sine or tan, not tan, but cos and sine, then you need to apply the squeeze theorem. So let's say you have this thing, and then you just say, okay, how did they get to this thing? Basically, they had cos of x, and you know that cos of x is between these two ranges, -1. So they had cos, and then how did they get from this to that? So they multiply in with e to the power of -2x. So if you multiply e to the power of -2x on this function, you have e to the power of -2x cos of x less than e to the power of -2x. So you have something like that. And now introduce your limit. So you can just unwind it or something like that. But then you can actually work with your limits here. So you have a limit of x approaches infinity of this function, which is e -2x. And then write the other one here, limit. You see, it's actually very easy. And if you got this far, you actually managed to do it. Well done. And then if you have something like this one, you know that limit of let me just write it down. Limit of x approaches infinity of 1 over x to the power of n is basically 1, because if you put an infinite number in there, it will give you 1 over a huge number, which is 0.0000 something. And then okay, let's work this one out. This one you don't need to work it out, you can just rewrite it again as limit of x approaches infinity of 1 over -e2x. And you can write this one the same. So we can conclude that this one is basically going to give you 0 as the answer. And then this one, it's the same thing. Sorry, my camera wasn't focusing there. So since this limit and that limit is the same, that means that it does exist, number one. And number two, the limit of this whole function basically equates to 0. So you're done.